water inside her. So I'll write clearly empty. Understood? So what are the forces that will be acting? The buoyant force. It's a practice of showing like this, and the weight m1g, or capital M is telling. Okay, this is a buoyant force. So now, okay, let's get into the radius part. Half of the immersion, no? So 2 by 3 pi r cube density of water rho w into g equal to m into g. So m is equal to 2 by 3 pi r cube rho w. So we know all the values. Sorry, like we have to get the radius, no? So solving for radius, r cube is equal to 3m by 2 pi rho w. Everything in grams only you put it because everything is available. So with this, what happened? We'll get the expression for radius. Okay, afterwards. A small coin of mass 5 gram is dropped into the pot. Find how much more the pot will sink. Change in height of the pot, it will sink that one. So definitely, so what I do is like, so when I add up, are you able to understand? So there's a displaced liquid, no? So some it will sink more further into the water. Okay, this is what is asking. Carefully make observation. I'm showing little bit thick, so that will be easy for you. So what we have to calculate? We have to calculate this delta H. When some coin is added, where do that coin will come and settle here? Able to understand? These are the diagrams. It's all about the, you should focus more on the diagram. That's what I feel. Huh? Okay, now what will happen to buoyant force? Slightly it will change, no? So what are the forces that are acting mg as it is? Weight mg, this is small mg, and this will be buoyant force plus additional buoyant force. Shall we write like this? Additional buoyant force, that'll be better for us. Why do that additional buoyant force? Due to this additional volume of water, as the pot got further immersed here. Again, once again, I'm writing it is emptier. It is empty. Let's get into this one. This is the equation 1. Now what to do now? So shall we write only that FB plus delta FB is equal to mg plus small mg. These two will get cancelled out. So again, we'll end up with only this much. So what is the additional buoyant force? Additional buoyant force should be equal to density of water, volume immersed, pi r square delta H into G. I think this will really trouble you. Just it's like a find how much more pot will sink. Express your answer in terms of change in height of the pot that is underwater. So when you put a coin, so what do you expect? Like slightly it will change. Still what will happen? only this elemental disk will come. Pi r square into delta H. Sir, how come you can say radius? Because the disk will be of like this. Will you agree this? There's a volume immersed, no? This will be a volume immersed. This is a delta H. And how come you say, sir, here radius R, but what about radius here R dash? Delta H is very small. Of course, it's a small what we are calculating. So you can just go for some additional increment in level of liquid. Okay, clear now? This will be. So I think now dividing 192, we'll get expression for delta H straight away because everything is in grams. No, this will be, let me divide 192 and dividing 2 and 1. So dividing 2 and 1, rho pi r square. So this will be delta H delta H by R look at one's equation. Do we know R? Yes, we know R. I'll bring it from here. Okay, I think the biggest trouble for you is like how come volume immersed is this much only? I know that there's a volume immersed. Delta H is so small that almost we can assume it to be circular disk. Fine. You check answer later on. I'll just give the data. 0.4 millimeter. Most of the questions will be like this only. Even I took sphere, no, there's a pot. Even conical flask will be there, will had some quantity. So slightly the conical flask will get into water. Still what will happen? The approximation will be like this only. Fine. The approximations what we do will be of like this. Almost all the numericals what we discuss, most of numericals. Only when the change in level is appreciable, delta H is something large, then we should not discuss in this way. Is it okay now? Slightly delta H will be very small. You can see now. Is it not small? 0.4 millimeter or almost like a 40 micrometer will be very small. If this change in level is of appreciable like a 1 centimeter, 2 centimeter, you should not think like this. Huh? You should really find out the volume. I'm making things clearer. You should not scold me, sir, like you're teaching all nonsense things.